Our first question is, consider the NFA M shown below. Let the language accepted by M be L and L1 be the language accepted by the NFA M1, obtained by changing the accepting state of M to a non-accepting state and by changing the non-accepting state of M to accepting states. Which of the following statements is true? So let's interchange the accepting and non-accepting states. This will be our non-accepting state, accepting state, and this is our initial state. Since our initial state is our final state as well, it means it can accept epsilon, and by taking 0 1 we are reaching at this state, and this is also our final state, and we have a self loop of 0 1 here. It means it can accept any combination of 0 and 1. So acceptance of any combination of 0 and 1 including epsilon can be represented like this: 0 1 star. So correct answer will be B. Our next question is, let W be any string of length n in 0 1 star. Let L be the set of all substrings of W. What is the minimum number of states in a non-deterministic finite automata that accepts L? So first we see what is a substring. A substring is a contiguous sequence of characters within a string. Let's take some examples. Suppose my string is 0 1 0. So its corresponding substrings will be epsilon, because epsilon is a substring of all these strings. Next it can be 0 or 1, 0, 1, and the substrings of length 2 will be 0 1 or 1 0, and the string itself. In order to construct an NFA which can accept all these substrings, first consider the largest substring. So it will accept 0 1 0. This will be my final state. Next it is accepting 1 0. So 1 0 1 0. Next is 0 1 0 1. It means this will be my final state. Next is 1. It is already accepting 1. This is my, because this is my final state. Next is 0. It means this will also be my final state. And since it is accepting epsilon, it means my initial state will be my final state as well. Let's take one more string, that is 1 1 0 1, and substrings will be epsilon 1 0 and 1 1 1 0 0 1, and the substrings of length 3 will be 1 1 0 and 1 0 1 and the string itself. So again construct the NFA for the largest substring. 1 1 0 1, and this is our final state. Next is 1 0 1. So we already have here 0 1. It will be 1 0 1, and it is already a final state. Next is 1 1 0. So 1 1 0. This will be our final state. Next is 0 1 0 1. Then 1 0 1 0. It is already our final state. Then 1 1 1 1. This will be my final state. Then 0. It is already accepting 0. Then 1. So 1. It means this will be my final state. And since it is accepting epsilon, so this will also be my final state. Here number of states are 1, 2, 3, 4, 5 and the length of the string was 4. Here states are 4, 3, 4 and the string length was 3. It means number of states are 1 more than the length of the string, that is n plus 1. So correct answer will be C. Our next question is, what is the number of states in minimal NFA which accepts set of all strings in which the third last symbol is A over the input alphabets A and B. So to be the symbol at third last position, here we have two options, and at this position either you can have A or you can have B, and again at this position either you can have A or you can have B. Similarly, here also you can either have A or B. So these are the minimum length strings which belong to this language. Let's construct an NFA for these strings. After taking A, you can either take A or B, and again after that you can either take A or B, and you should reach to the final state. And since there is no restriction at the beginning, so we can apply a self loop here. Now let's check whether it can accept these strings or not. Triple A, accepted. AAB, accepted. ABA, accepted. ABB, accepted. So this is the final NFA corresponding to this language. So how many states we have here? 1, 2, 3, 4. Correct answer is B. The question is, let W be any string of length n in AB star. Consider L be the set of all strings ending with at least n A's. What is the minimum number of states in non-deterministic finite automata that accept L? So first consider the set of strings ending with at least 1A. So its corresponding NFA will be at least 1A. So minimum length string will be A. Now there is no restriction at the beginning, so we can apply a self loop. So it can accept what? It can accept single A, it can accept double A, BA, double BA, triple B, A. So it is ending with at least 1A. Next, at least 2 A's. So its corresponding NFA will be, and here we can apply a self loop. So it is accepting strings like double A, B double A, double B double A, AB double A, or B triple A. So it is ending with at least 2 A's. Next, take at least 3 A's. So similarly, it will take 3 A's and then it will reach to the final state. And here we can apply a self loop. So when it is at least 1A, so number of states are 2. When it is at least 2A's, number of states are 3. When it is at least 3A's, number of states are 4, which is 1 more than the number of A's. Okay, so correct answer will be n plus 1, B. Our next question is, consider L, which is A power P star, such that P is a prime number over the alphabet A, then What is the minimum number of states in NFA that accepts the language L? So our language is a power p star, and p is a prime number. So value of p can be 2, 3, 5, 7, 11, 13, 17, etc. So since there is a star, it means it can accept epsilon. Next, it can accept double A, or it can accept triple A, and after that it can accept 4 times A. How? If I take this A power 2 times, and then A power 5, if I take 2 times A power 3, so it can accept A power 6, then A power 7, A power 8 if I combine these two, A power 9 if I combine these two, and so on. So it means it is accepting epsilon and the number of A's greater than equals to 2. So to accept epsilon, our initial state will be our final state, and to accept 2 A's, this will be our NFA, and after that you can apply the self loop. So how many states? 1, 2, 3. 3 states will be required to recognize this language. So our correct answer is A. Our next question is, let N be an NFA with N states. N is an NFA having N states. Let K be the number of states of a minimal DFA which is equivalent to N. Which one of the following is necessarily true? So this is the thumb rule that number of states in DFA will be less than equal to 2 power number of states in NFA. So number of states in DFA is K, and number of states in NFA is N. So correct answer is D. This is the thumb rule, so please remember it. We can use another approach to solve this question. So we can take the help of transition function of NFA and DFA. In DFA, from a state, by taking an input, we can reach to exactly one another state. But different from this, in NFA, we can reach to a number of states, which is 2 power q. And we know that q is a subset of 2 power q. And in DFA, it is given that we have k states. And in NFA, we have n states. So replace this q with n. So this is the relationship, or you can just directly remember it. The number of states in DFA will always be less than equal to 2 power number of states in NFA. So correct answer is D.